All right, we're going to go ahead and get started. So welcome to, this is CSCE 215, Unix Linux Fundamentals. So hopefully all of you are in the right place. So before we start, I like to gauge, also I should probably introduce myself. I'm Peyton Chandarana. First and foremost, I'm not a doctor. I'm working on my PhD. Just because I haven't gotten my PhD doesn't mean that you're getting any less of a quality of education, right? I know my stuff. I'm here for a reason. So I can assure you, I'm here to help. I want you to be confident that I know what I'm talking about. Just because I don't have the doctor or doctorate yet doesn't mean I don't know my Unix and Linux. Okay, so just before we start the lecture, how many of you are freshmen? Okay, so most of you, that's pretty expected. Sophomores? Okay. All right, juniors? Okay, seniors? Okay, so who's in the computer science department now? Okay, so most of you. It's a prereq for most of your coursework. Who's not a computer science major or computer engineering or CIS? Okay, so we always have a couple. I always like to gear the course towards the next course, which is like the hard course of computer science and engineering. But I hope that for those of you who are not in this major or in the computer science department, you'll find value in this class as well. So go ahead and see if it clicks. Okay, so like I said, my name is Peyton Chandarana. You can call me Mr. C, Mr. Peyton, Peyton. First name, I'm not a doctorate, you don't have to call me that. So yeah, or professor, like professor is a title to be earned.
So we call you Mr., I just want to make sure.
Peyton, Mr. C, Mr. Chandarana, whatever you want to kind of do. Just don't call me doctor. Not there, I'm earning it, working on it. Okay, so I'm from here. I got my bachelor's in computer engineering from this school. So I know what you're kind of going through, most of you. It wasn't that long ago. I'm only 26 years old, so I'm not that old. So I graduated in 2019. Now I'm working on my PhD. I started as a master's student. I kind of hopped around in different labs and everything like that. I started in a lab in the nursing school, helping out with some app development. Then I went on to doing some like COVID protein work, and now PhD student. So now I'm a PhD student. And my primary research is kind of on AI, machine learning, deep learning kind of topics. Primarily what's called neuromorphic computing, which is like a neuroscience-inspired computing kind of thing. So that's enough about me. So why are we here? So anybody want to answer why are we here?
To learn about Unix and Linux.
That's one reason, yeah. All right, anything above Unix and Linux is just other than just Unix and Linux? Anybody got any other answers? Okay, shy. Okay, get it, first day. So why are we in this class? Let's answer this first. So obviously, Unix and Linux, you're in the Unix Linux class. Also, those of you who are sitting on the floor, try to squeeze in if you can. There's one more chair up here that you should be able to, you might have to ask somebody to kind of squeeze in, but it's okay. All right, so why are we in this class? We want to try to find what we need to find efficiently, like searching things, right? So some people have this really resourceful kind of innate ability. Those of you who do not have it, you're going to have to figure out how to do it. So what I mean by that is how to Google, right? In this course, we used to make fun of it in my undergrad as we called it Google 101. How to Google things, because I can never teach you everything about Unix and Linux. There's just not enough time. Just not enough time. There's too much. It's like me teaching you everything about Windows, how to use Microsoft Word, everything like that. There's not enough time in the course. Nor do I think you want to learn everything about Unix and Linux necessarily. So first of all is how to Google to find what you need. Another thing is how to use Control F or Command F, depending on the computer you're using. So you need to be able to find what you need to do efficiently on the Unix, Linux, and just in general. How to be lazy or AKA efficient, like make your job, make your life easier, and then work smarter, not harder. So write one script, write one program that does everything you need it to do, and then run it again when you need to do it. So make it kind of generalized. All right, so what about college? So for those of you who came to college to learn knowledge, that's not what you're here for. A lot of people fool themselves into thinking college is about just learning a certain set of knowledge, especially in computer science. Everything changes weekly, daily, yearly. So we're not here to learn just a subset of knowledge. It's always adapting. So you have to learn how to learn, not just learn one specific topic or one specific thing. If you're in computer science especially, you have to learn how to constantly adapt and upgrade your toolbox of skills. All right? Obviously, we're computer engineering and science. There's a stereotype that we're not good at socializing. So obviously, college can help with that a little bit, socializing, professionalism. And please, when we're in the lab this week, don't just stare at me blankly silent. Talk to your neighbors. Help each other. It was like last semester in the summer that I taught it. It was just silent, dead silent, the entire class, and it's excruciating for me. So please make some friends and stuff. Exercise that socializing nerves and whatnot. All right, so, and then we want to cultivate our knowledge, like expand it. It sounds cheesy, it sounds corny, but we want to try to be the best version of ourselves that we can be. That's what college is about. You're trying to teach yourself how to learn and how to be passionate about a topic. And obviously to give you some ambition. So once you're in college, especially right now that you're in college, start thinking about what you want to do, what you enjoy doing, and become passionate about it. Find what makes you happy, because it's nice to work in a job that you enjoy, right? Okay, so that's why we're in college. Not just learning a subset of knowledge. All right, so one of my people that I look up to was Stephen Hawking. So he has this quote, and this quote, I'm not going to read it necessarily. It's here for you if you want to watch the little video. It's a nice little inspirational video. This quote is basically saying what I just said. Find something that you're passionate about. Be curious about it. Always don't be afraid to tinker, right? We're going to be in the Linux labs. You might be sometimes scared that you're going to break something you're not. You do, it's fine. Like, don't be afraid to tinker. Don't be afraid of failing or messing up and learning from those mistakes. That's the important part. All right, so in classical form, we're going to go over the syllabus real quick. Not that one. Okay. So we're not using Dropbox. So I sent you all an email over Dropbox. You probably received like 2 emails from me. One was from Dropbox, one was from Blackboard. We're not using Blackboard. Do not use Blackboard at all. Nothing is going to be on Blackboard. Your grades, all your assignments, all the lecture slides, lecture videos, everything will be hosted on the departmental Dropbox. So dropbox.csce.sc.edu. Try to log in with this. If you can't log into this portal, then you can't log into the Linux lab machines. So this week it's not that important, but starting next week in lab, you need to have access to this website and the Linux labs. So if you can't access this website with your university credentials, email me. Try to troubleshoot it yourself first. Email me, and then we can figure something out, get you up and running. So yeah, you just use your username for the university. Same password you use for your email. Of course, I can't type. There we go. And you'll get to a website like this. And you'll see a little penguin sitting like this, awkward little penguin. And this is the class. So it's 8XY. So this is the combined group or like submission place for everyone in the class. So all of you are split up into 8 sections. Those 8 sections basically correlate with your labs, your lab times and registration. All right. So the syllabus is already up on Dropbox. So happens from now till May. So the textbook's not required. So this is an optional textbook. It's free online. You can use it. For the most part, I recommend Google as your textbook, right? All you have to do in Google is type how to do blank in Linux or how to do this in Bash, yada, 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 right? So you don't really need a textbook. You can use it. It's good for supplemental information, and I've also provided some links on Dropbox that might help. But for the most part, I think Google's learning how to be really fast at looking at Stack Overflow is a really good skill to have. Okay, so here's your labs. So we have 8:51 through 8:54 on Wednesday, 8:01 through 8:04 on Thursday, I think. These are required labs. You have to come, like, especially at the beginning. You have to come in person. I can tell when you submit your assignment if you were in the Linux labs or not. So come to the lab, do your assignment. That way you can get it done and don't have to worry about it. All right. So these are your labs. Your lab is in 2 doors down this hallway. It's 1D43 on here. And it has a key code right here. So 15234. You just punch that in and you twist the doorknob and you can go in. It's available 24/7. You can go on there on the weekends. You can go on there holidays. It doesn't matter. As long as the building's open, you can get into the Linux lab. So you can do your homework at 2 a.m. on a Saturday if you want to. But yeah, so yep. So that's the labs. There are other Linux labs, which we'll go over in a second, located in Swearingen. You don't have to use those. If for some reason that lab is full, you can find the other one and use it. But we have 2 parts to the final exam. So there's 2 parts. There's a multiple choice, knowledge-based exam to make sure you know what your commands are. And then there's a project part. And the project part you have to come in person for. The other part you don't necessarily have to come in person for. So those are kind of the tentative dates of when the final exam should be. Yes, there will be open note and open internet and whatnot. Okay, so I'm going to kind of try to rush through this because I want to try to get through all the slides. Okay, so like I said, I'm Peyton Chandarana. That's my email, pretty short and simple, psc@email.sc.edu. I have office hours in the Innovation IBM building. It's right up the street on Assembly in Blossom. And I'm supposedly going to get an office, a dedicated office for office hours, but office hours are Monday and Friday, 12 to 2. We have 3 TAs. So we have, I think one's here, Masa. So this is our full-time TA. She'll be handling most of the quiz grading, and she might be helping with the labs a little bit. So then we have Fawad. So Fawad and Chao Yu are both kind of remote TAs a little bit. They will be kind of on campus, more or less. So if you need to meet them in person for some reason, then that's fine. But otherwise, they're available on MS Teams at those times. All right, so again, we're not using Blackboard. We're using Dropbox. Did everyone receive an email from Dropbox? You should have gotten 2 emails from me. Everyone get it? If you didn't, let me know. Because I'll be sending emails in the same way over the semester. I'll probably send one more test email just to make sure everyone is getting them. All right, so course structure. There's 4 categories of assignments we have. We have quizzes, lab assignments, homeworks, and a final exam. And the only 2 things that you really need to know right now is that homeworks and lab assignments are weighted very lowly. So if I scroll down, I'm not going to go through the objectives. You can look at those if you want to. You'll notice that quizzes are 30% and the final exam is 30%. Right? So those 2 make up 60% of your grade, your final grade. So if you don't do well on those 2 things, i.e. you cheat on the lab and homeworks, then you don't pass, right? So you have to do well on the quizzes and the final exam to pass the course. So last semester we had a midterm. Some people on my evaluations, which I took seriously, said that they didn't like the midterm. They didn't want the midterm, so I took it out. It makes my life easier too. So we'll have more quizzes throughout the semester. And yeah, so, and then the final exam. So this makes your life easier too a little bit. So no more midterm, yeah. So they're gonna be, we're probably gonna have about 10 of them throughout the semester. So there's 15 weeks in the semester or so. So probably every other week, maybe a couple overlapping weeks where we'll have one consecutively week to week. So yeah, so we'll have a quiz about every other week or a little bit more often. Homeworks, you'll probably have 4 or 5 of them throughout the semester, so 1 per month. Yeah, so does that sound reasonable? Like, that's a reasonable course load. So one thing that the department, and I've just heard in general professors say, is you're supposed to spend double the amount of credit hours at home on your homework. So if it's a 1 credit hour course, you're expected 2 hours a week at home of homework or studying or whatnot. If it's a 3-hour course, then it's 6 hours at home. So sounds rough, but like that's just kind of what we guide our like assignments and everything off of. So yeah, if the course becomes maybe too hard or it becomes more challenging than you think it's worth for 1 credit hour, talk to me and I'll try to adjust some things, right? Give me feedback. This is a two-way street. It's not just me saying, okay, you do work. Talk to me. We can communicate. We can figure things out. We can kind of adapt as things go. If we have a blizzard for some reason, we can work around it, right? Last semester's hurricane season. This semester, maybe have a blizzard for the first time in 10 years. Okay, so yeah, so keep this in mind throughout the semester. So know that quizzes are weighted heavily. Be prepared for the quizzes. So think about the labs. The labs are weighted very lowly. They're basically attendance grades. And if you try, you get 15 out of 15 points on them. So if you come into the lab, you get basically 5% right away. If you try on the assignment, it looks like you put a good effort in and have a good quality submission that somewhat meets the requirements that I set forth, you get the rest of the points. So it's more or less a freebie. So get your free lab points, yeah. No, not really. So this course is about practice. You've got to practice, practice, practice. If you don't practice the commands and spend those 2 hours a week outside of class practicing or getting to know Linux, you probably won't do well. You need to practice. That's why I more care about you showing up to the labs than even the lecture. So if you don't come to the lecture the entire semester and you do well in the labs, I don't care. Like, I would like you to come to the labs because I'm going to try to make them beneficial, but please come to the labs. It's required. If you don't come to the labs, you're not going to get 5% of that lab grade. Yeah.
Are you posting the lectures online?
Yes. So the lectures are going to be, the slides will be posted. This one's actually already posted. And then the YouTube videos, new set of YouTube videos will be on YouTube. So I have last semester's YouTube videos already on YouTube. And then this semester, we'll have more YouTube videos. So I'll be providing plenty of references and resources for you to look at and help you throughout the course. All right, any more questions about, yeah? Haven't decided yet. They're most likely gonna be paper quizzes. So that brings me to my next thing. So quickly, this is the schedule. Next week we don't have lecture, don't show up. We will have kind of more or less a lecture in lab. I added a lecture from last semester so that I can actually go over something that people found more challenging. So yeah, that's the tentative course schedule. This will probably change at some point, maybe, depending on how the course goes. Okay, so this brings me to the next thing. The reason I have the course set up with 60% of your grades being assessments, that is quizzes and final exam, is because of cheating. This course has been not taken seriously in the past. When I think this course has a lot to offer you if you take advantage of it. A lot of people have cheated before. I've caught some myself. I've been a TA for many years. This is my 3rd semester teaching the course. And I try to make it impossible for you to cheat. So I have a little bit of a different viewpoint on cheating than most people and most professors or instructors. If you're resorting to cheating, there's either 2 things that are going wrong. Either I'm doing something wrong, which is when you should give me feedback and say, hey, we're not understanding this. Can you go over that again? Like, talk to me, communicate with me. Or you're making a choice to cheat. You're making an actual decision to waste the money that you spent on this course, right? So don't make that decision. Please, don't. I've caught people, trust me, I'm clever. If you think you're clever, I'm clever too. So don't cheat, please. So yeah, the quizzes, we're gonna have proctors. I'll be watching when you take the quizzes. We'll probably do them in lab, most likely. They'll probably be on paper because that prevents cheating to some extent. You can't be using a resource with the quiz if I don't say you can, and I'll catch you if you do. And then the final exam, obviously, you can use outside resources, but I'll still catch you because I'm pretty clever. Just don't challenge me like that. If that sounds like a challenge, don't do it. Like that is not a challenge for you to try to cheat because you won't get away with it. I promise. Okay. All right. Anyone gonna cheat? Raise your hand. No? Okay. We can just get it over with? No. Okay. All right. So good. 0% cheating this semester, please. Don't. I have to fill out a huge amount of paperwork. It has to go to the academic integrity. It's a huge hassle for you and for me.
I mean,
So.
to be fair, if we were going to cheat, why would we say that?
Yeah, I know.
I'm sorry. It's just
Yeah. No, that's the point. Sarcasm. All right. So attendance, like I said, I could care less if you come to lecture as long as you know the material that was taught in lecture and how to do it. Again, you can go at home on the weekend, watch the lecture on YouTube if you want to. I don't care. But you have to come to lab. It is required. There is no option. I find that students' grades start falling when I let them take the labs remotely because they don't complete it. They come up with excuses and whatnot. Okay, so late assignments. So late assignments and assessments. For assessments, for quizzes in the final exam, you have to have a reasonable excuse with documentation. I will not let you take them, retake them otherwise, or make them up otherwise. And it's my discretion to change those. So if you miss one, I have the right to change that quiz or that final exam to make sure you don't cheat and get resources from other people. So I have that right. So that's assessments. You have to have a documented reason for the quizzes and the final. For the homeworks and labs, the same policy applies where you have 3 days, late days. You can say there's a deadline on Friday. You have 3 days after Friday to submit it for credit. After those 3 days elapse, it's a 0. So it's 10% off per day. So as soon as you spend those 3 days, it's a 0 after the third day. So does that make sense? So you have 3 days after the due date to submit. Each day it's 10% off at its late. That's for both homeworks and labs. The labs have a special treatment. Labs are either on Wednesday or Thursday for all of you, but you have until Friday night to get full credit. So if you submit it at Friday night at 11:59 p.m., then you get full credit. But 3 days after that, if you don't submit it by 3 days on, I think, Monday or Tuesday, then it's 0. So you can do labs late, you can get full credit by Friday, but as soon as you hit Monday or Tuesday the next week, then it's a 0. So another thing to mention about labs. Labs are, again, weighted 15%. Do not spend a ton of time on the labs. Do what you can. Try to put a good effort forward, and as long as myself and the TAs can see that you put a good effort forward to actually understanding the material and doing what I ask, you get 100. Like I said, the labs are a safe place where you can try to expand your knowledge and try new things without getting penalized for it. All right, sound good? 15% for basically free if you try. All right, any questions? Yeah.
How long will the quizzes be in a given?
15, 20 minutes. All right, so disability accommodations. If you have disability accommodations and you want to use them in this course, please have the SDRC send me the actual official email with the form for the accommodations, and we'll make those accommodations. A quick note about this: if you do have accommodations and you want to use them, the TAs will grade it the first time, and if you have like an extra day on your assignment or something like that, the TAs may take off points for it. but tell me, communicate with me if this happens, and then I will go in and regrade it, right? So TAs do a pass, and then I go in and adjust grades for accommodations, but keep track of your grades is what I'm saying. So if you get a grade that you don't expect, talk to us, communicate with us. All right, so outside of disability resources, for other course help, there are several things that are here to help you. There's the Student Success Center, the internet, obviously. There's tons of help on the internet, tons of forums. There's Stack Overflow, there's Reddit, there's all kinds of things. If you just search how to do something in Bash or Linux, it usually gives you good results, at least with Google, maybe not Bing. We won't talk about that, though. Okay, and then there's a third bullet point that I should have added. We probably will have a official SI. I don't know who they are yet. I need to find out. But I usually don't have control over that. I'll probably try to meet the SI, but yeah, the SI should be available at some point, or the tutor or whatnot. Okay, and then finally, this document can change, right? So I can adapt it and update it if I want to, if something needs to be changed. Okay, so done the syllabus. So just a couple key takeaways. Keep in mind the grading scale. Like I said, don't spend all your time on the labs. They're weighted very little. Submit what you have by the deadline. At least submit something by the deadline, right? And then keep working if you want to. If you find it that it'll be advantageous to you to keep working to get a higher grade on something, then do it. But just keep in mind the deadlines and the policies. 3 days late, max, or it's a 0. All right. Again, you should expect about 2 hours of work outside of this course, outside of the actual course designated course hours. Yeah.
I have a question. If you submit something wrong, but you email the professor and you submit and you show them what you have, but they don't get to it the next day, what would happen then?
You don't email assignments, you submit them on Dropbox.
I know, but I've had trouble on Dropbox where I've only submit once.
I won't be doing that for the most part. You will always be able to resubmit an assignment. And if you have any doubts, I would just rename the assignment to a different name and re-upload it, and I can probably see the last modified date. But for the most part, you can resubmit as many times as you want. But just keep that in mind. If you submit it late, then it overwrites your previous submission. All right, so labs and homeworks can be submitted up to 3 days late. Otherwise, it's a 0. You get 10% penalty per day late. Again, lab attendance is required. Please show up to the labs. I put a lot of effort in them. I'm doing all 8 labs. So that's 4 labs on Wednesday and 4 labs on Thursday that I spend with you, back to back, 50 minutes each. So I put a lot of effort into them. So please try to come. Or you're required to come unless you're sick or have some personal issues. Final exam has got 2 parts required. So you have to come 2 days at the end of the semester. There's no allocated final exam date for this course. So I make it the last 2 or 3 days of the course for us. So the last 2 or 3 sessions of the course, you'll have your final exam because we don't have that dedicated lab date. So that's one less final exam you have to take during the finals week. All right, so big point. You, not me, not the TAs, are responsible for ensuring that your assignment's uploaded correctly. So after you submit your assignment, you download it from Dropbox and make sure that what you submitted is what you think it was, right? Something can happen over the network, something bad can happen, like maybe you didn't submit the file that you thought you were, right? So just download your assignment, check it, and then if it didn't upload correctly, keep trying to upload until you're sure that what you submitted is actually what you wanted to. All right, and read the syllabus. So we're gonna have homework soon. Part of the homework is you agreeing to a statement that I read this syllabus in its entirety. The syllabus is our contract between you and me, right? It's you saying, I agree to the terms that Peyton has put forth in the syllabus, that I agree to follow those rules, right? So read the syllabus. If you don't like the syllabus, then sorry, I mean, I can work with you. I'll listen to all your feedback, but I'm not sure if I'll change it. All right. So quick history. We're just going to blow through this. This is not necessarily something you need to really dedicate a lot of time to learning. Also, I'm sorry if I sound like a hard ass. I don't mean to sound like I'm kind of extremely strict. I'm actually pretty easygoing and pretty understanding, but just being a little bit firm. Okay, so history. So idea of digital computing kind of started with Ada Lovelace and her colleague Charles Babbage. They developed the first kind of digital computer. It used gears and like mechanical. They didn't have like circuits and everything like that back then, or at least not the circuits we know today. So back in the 1800s, they had the first kind of digital computer. It was based off of, it looked like that. I think that's actually a picture of it. Then we have Alan Turing, one of the so-called gods of computing. Came up with he broke the Enigma code. There's a movie out of it. It's really good. If you haven't watched this on Netflix, I highly advise it. He broke the Enigma code. He developed the Turing machine, which everything in computing, all programs that you write, all programming languages today are Turing complete. You can take that programming language and apply it to a Turing machine, and it will work. So if you don't know what a Turing machine, it has an input tape and an output tape, and you basically read and modify things on the tape. But yeah, everything that we know today is Turing complete as far as computing goes. You got the Turing test about how to define intelligence, and he was kind of first of the forefathers of artificial intelligence. All right, then we have John von Neumann, another god of computing. He kind of built the architecture that we're used to today. So when you have a laptop or a desktop and it has a CPU and memory and it works on and computes inside that memory, or it modifies that memory, that's his responsibility. He was the one that came up with that architecture design, right? All right, so analog and digital computing. So you have two different types of computing. You got analog and digital. Analog used to be kind of phased out for a little while. It's coming back now. But it kind of used to be kind of thought as, okay, well, it's kind of archaic. We're not going to do it anymore because it uses gears and mechanical kind of parts and stuff like that. But it's really good at continuous domain computing. So if you know of computers, they use zeros and ones, bits, right? So that's what analog isn't good at. Analog's good at doing things between 0 and 1, kind of like quantum computing or something, in superposition. So analog computing used to be mechanical and kind of a continuous domain kind of thing. Digital computing, that's what we're used to. That's what all your computers are based off of. Little electrical pulses on and off, or high and low. All right. So just think of, when you're thinking of analog versus digital, think of how a floating point decimal is represented in binary versus how it would be represented in analog. So like I said, I can see that most of you are bored with this, so I'm going to kind of move through this. Circuits, voltages, and currents, different in both of the different domains. And now we're at transistors. So we started out with switches. Zeros, one on and off, high, low, 0 and 1, right? And then we go into transistors, right? Transistors are the foundation of those switches. Like, they're really tiny. Like, your cell phone has billions, if not trillions, of transistors. All right, and then you take those transistors, which are basically switches, and you create gates. You have all your different gates, NAND, NOR, XOR, whatever, XOR. And then out of those gates, you make ALUs, or arithmetic logic units, which are doing the operations like addition, subtraction, multiply, division. All right, so that's all the hardware fundamentals. So you start from little tiny switches, all the way up, go to gates, and then you form algebra, kind of algebraic units out of that, or arithmetic out of it. Okay, so how about I/O? Started out, again, with switches, right? Switches and plugs, turning on and off. We have light bulbs. That's kind of showing you that, hey, something's working, something's being processed. You have punch cards. So you take a little card like that, piece of paper, punch little holes in it, and feed it into the machine. Now imagine, my mother actually had to do this, carrying a stack of punch cards that you had to feed into a machine, and then tripping and falling and losing all the punch cards. They usually got numbers on them, but But still, that would suck, wouldn't it? So yeah, we came a long ways. Then we have screens, right? Then we have a keyboard. So same idea as a typewriter, inspired by the typewriter. We have printers. And then we have a mouse. Mice are actually fairly new in the last 30 years. So 30, 40 years ago, we didn't have mice, right? So they're fairly new because you had to invent this thing called the GUI, graphical user interface. And you can actually sit there and click on things. So we'll learn about why using keyboard is superior in this class. I think a lot of you probably think, oh, I like a mouse to do my stuff. Well, I think I'll change your mind a little bit by the end of the course. All right, so programming languages. So we did the hardware fundamentals. How do we take that program that we write and put it on that hardware, right? So we start out with what's called a human readable or high level language. That can be Python, C++, C, Java, any of those. Those are all high level languages. And you write those. Those are the ones you're familiar with. And then it goes through like a big hierarchy of how to get it all the way down to binary. So first we go from the high level language to some kind of compiler along the way. Then that compiler takes the high level language and converts it to on and off or binary. So there's two different types of languages here. There's interpreted versus compiled. There's caveats and pros and cons for each of them. We got two examples, Python, C++. By the way, C++ is most likely what you'll be using in 240, the next course after this, the one that this course is the prerequisite to. So yeah, I went over this abstraction level. So you have your language that you're used to writing in. You go to the assembly, which is from the compiler, and then goes to binary. So high level language, good. You're familiar with it. You can write it. Assembly, you can do it. It's kind of nasty. Machine code, good luck. If you can read binary, thousands and thousands of bits of binary, please see me. You deserve a PhD right now. All right. So operating systems. So this is Unix, Linux. Unix and Linux are just operating systems. They're big loop programs. They're basically a big while true loop, and you're just doing things in that loop while it's running. So what does it do? It manages hardware usage. So it manages all the different architectures and things and orchestrates them, organizes them to accomplish this task, does process handling, I/O, etc. We have easy programming. So it really makes programming easy. Imagine having to write a program in assembly or binary every single time you want to deploy something on hardware. Instead, you go inside the operating system and you can write it and deploy it that way. The operating system handles all the I/O and whatnot. Okay, so different approaches. There's tons of different operating systems. There's Mac OS, Linux, Unix, and Windows. We won't talk about that. I think I'll also prove to most of you that came in here thinking, oh, well, gaming's good on Windows. Windows is clearly the superior operating system. Yeah, I'm going to prove you wrong. So, history of operating system. Unix was first. Sorry, DOS and Windows. It was written in assembly. Have fun with that. And then we have Unix-like with Linux and Linus Torvalds. We'll talk about him. And then we have BSD. Then we have MS-DOS, precursor to Windows. Mac OS built off of BSD. Windows built off of DOS, etc. So, and then we have Linux distributions. So in this class, we're focusing on Linux, right? Slash Unix, kind of similar. There's differences though. Specifically, the lab computers have Ubuntu. So if you want to nuke your install of Windows or whatever, if you want to install Ubuntu yourself, you can install it. Personally, I like Arch. So yes, I'm going to flex on it, all of you, and say I use Arch. Those of you you'll probably understand that joke in a little while. So, okay. So let's look at a couple links real quick. Okay, so this is the tree of Unix. So we go all the way from this, let's see if I can pull it up. Go from this unnamed PDP operating system, then we go to Unix, and then we trickle down, and guess what? Here's BSD, oh, what is this? There's Mac OS right there. So Mac OS, reasons you see a lot of computer scientists using Macs is because it's Unix based, right? So you've got a command line that's very similar to Linux. And then you have this vertical line that has Linux over here. So Linux is separate from Unix. They're very similar. They kind of intersect a lot of ways, but they are different at the core level. One thing about Linux is it's completely open source. Not all distributions of Unix distributions or flavors are open source. Most Linux operating systems are. And one guy at the age, probably a lot of you at your age, created Linux by himself, as a college little side project. So he created Linux, the core foundation of Linux. So got a little bit of a challenge there. Build the next Linux. Hello? There we go. All right. Here's the Linux distribution tree. So I said that there's distributions of Linux. You can make your own distribution if you want. They're all have the same kind of back end, which is called the Linux kernel. But you got thousands and thousands and thousands of distributions of Linux that you can find and customize, make your own. So you can choose what you want. Lots of flavors. So that's already an advantage. You can't do that to Windows. Never. All right. So here's how Linux is kind of organized. So here's your hardware, your human interface devices. You've got your hardware. You got your display, things like that. And then you go into, you got your actual like computer, your CPU, whatnot. You got hardware over here, just in general. And then you go to the Linux kernel. So the Linux kernel handles and orchestrates all that hardware, like I said earlier. So the Linux is the operating system under the hood. It's orchestrating everything for you. And then you go to another level called the software level, kind of you've got, or the service level. This is where you have all your apps and software that you're used to. And it communicates with the operating system, which communicates with the hardware. And then I added, here's Linux. This is it. It's on a GitHub repo. You can go and contribute if you want to. If you want to be in the history books of I contributed to Linux, then you can go help Linus Torvalds develop it if you want to. Don't have to, just something some people like to do. All right, so this is how Linux is structured. You've got the hardware, you've got the kernel, which is something, those two things are kind of set in stone. You don't want to really modify either of those unless you know what you're doing. And then on top of that, you have a shell, which is the very most basic version of software that you can use, which interacts with the kernel and can go through the levels and go down to hardware. That's not mine, is it? Okay. And then you have software on it that's built up from there. So what we're going to be focusing on is this green level, the shell. So the shell, or the command line interface, is what we're going to be focusing on, how you look like a hacker, right? So what's the class about? The shell or the command line interface. Every single operating system that you know has a command line interface. And a lot of the skills you learn in this class will be able to be applied to Windows, to Mac OS. So you can use a command line other places than just Linux. Windows has PowerShell. Linux has Z shell, which is the flavor of a shell. So you got different shells. All right, another thing, how to navigate the file system better. We'll learn more about what the file system is and how it's structured next week in lab. But yeah, you can navigate the files. Instead of double-clicking on a folder every time you need to go somewhere, you can be a lot faster. How to use the command line. How to never leave your keyboard. How to throw your mouse out the window and never say, look back. And then how to automate and make your life simpler. And then, like I said, how you can look like a hacker. So if you've ever seen this, I don't know if you've ever seen anybody like a programmer doing this kind of stuff. This is the course that teaches you how to do this. How you look, you go into airport and people start worrying every time they look behind their back like he's hacking into the mainframe, right? So this is what we're going to learn how to do. You can scare people. All right. And like I said, Linux Lab's open. Course overview, yeah. See y'all this week.